Hi everyone, welcome back to this channel. In this video, I'm going to show you a quick setup to the new features that we have in the PNA family and also the USB VNA family that enable user to test out, to measure the EVM and the ACPR using a VNA machine. The traditional way to measure EVM is using a signal generator, and then you pump it through your device under test, and then you do the measurement using a spectrum analyzer. In Keysight, we have this software called Vector Spectrum Analyzer software, VSA software. If you are not familiar with that, this is a software that enables user to demodulate and to measure the quality of the signal in terms of EVM measurements, in terms of CPR measurements, in terms of CCDF measurements. I'm going to show you the comparison in terms of data between this new method, modulation distortion, versus the traditional way of using a spectrum analyzer and signal generator. So if you need more information, can you go to keysight.com and look for modulation distortion, and this option can go up to 70 gigahertz depending on your machine that you have. So let's get into it. So as you can see here, this is a remote setup that I have on the PNA, and I have a amplifier connected between port 1 and port 2. Amplification is about 18 dB gain. So how do I test it? Before we get into this, let's preset the whole thing so that you can see how I get into the whole setup. So this is how it looks like in the preset mode. And of course, we can always do a S21 where we can check the response, how it responds across frequency. So the amplifier that I'm using in this testing is the U7227F series. So it actually ranges from 2 to 50 gig. So this is how it looks like. And as you can see, that if I put the marker up to here, so it starts about 2 gig and all the way to 50 gig. Because there's a limitation on the gen that I'm using to test this. So today we're going to just focus on the 4.75 gig range. So it reaches somewhere about here. So currently the input power is -15, and according to the sticker on the preamp, it says do not exceed +10. Again, just for the sake of verifications, let's test it out using another options that's available in PNA. We call it gain compressions. So this features enables user to quickly find the P1 dB of the amplifier and then scale it down if you want it to work in the linear zone. Let's get to that. Go to setup, measurement class, and let's go to gain compression first. So this is how I check the response of the amplifier before I do anything on the modulation distortion, just to find out where is the linear zone, where is the saturation zone. And these are very good features to have. So quickly, let's set it to 4.5 gig start. And stop at 5 gig. I have bandwidth. It's alright because we just want to see a rough estimations. So power, let's start from -25 to -8. And compression, we're looking at P1 dB, so it's 1 dB. Once you're happy with that, let's apply and click OK. Let's turn on the marker here. So that's 4.75. At P1 dB is about 18.85 dB gain. And we can see what's the input power for that. Let's measure the input power, and then let's create another trace. Just look at the output power. Output power saturation is about -11.37 dB. In the modulation distortion, if we work about -15, we're still alright. So it's still working at the linear zone area. So let's get to modulation distortion setup. Let's go to setup, measurement class, modulation distortion. And click yes. Let's start with this area. Currently, I just want to fix the sweep. I don't want to change the power because I know roughly my linear zone. So I'm going to test about -15. So I set it to fixed sweep, center frequency 4.75 gig. And span, it depends on the ACP measurements that we're going to set up later. We will come back to revisit this area. And for the power, let's start with -20 so they can see some difference in the ACP measurements later. Let's click OK. Then go to RF path. Currently, I won't change anything here. Or maybe I just set it to additional 10 dB so that I'm pushing the external SIGGEN to the linear zone, anything above 0 dB. Okay. And this is especially useful when you want to have a better signal to noise ratio. This is where you're going to put in the internal attenuations on the VNA. I'm going to show you the difference with and without this 10 dB later, especially on the input side. So you're going to see the difference between the signal to noise ratio of the signal getting into the device on the test. And this, according to the developer, it doesn't really matter whatever value that you're putting in. Just to, when you click auto scale, you will try to put in attenuation just to protect your ADC. But as of now, it doesn't really matter. You can put in 18 because that's what we're seeing on my device. Or you can just leave it at 0, it still works. Okay, so let's put in 18 for now. Then we go to modulate. So this is where we need an external source. So I'm going to show you how it looks like here now. This is a VNA help file that you can download from keysight.com. It's an offline help file, but it contains tons of information about the general setup or general knowledge that you need to know in the PNA options. For example, we are looking at modulation distortion today. And this is how we get into it. Just go to content, applications, and modulation applications. This is how it looks like from my current setup. So we have a MXG. We connect the output of our MXG to jumper 10 at the back of the PNA. And this is the reference clock that I mentioned. So PNA should be the reference out, and MXG should be the reference in. So without this, I'm going to show you what's the difference with and without this reference clock connected. And again, you can find this setup in the help file. And do think about downloading this VNA help into your PC so that you can always have a reference guide in your PC anytime you need it. So let's get to here. So as you can see, we don't have any source here right now. Let's add source. And previously I have an EXG MXG setup. This is why you're setting the IP address if you need to know how to do it. You can also go back to the other video that I have, just to go through the step-by-step on setting up external hardware. So let's go to device property. This where let's uncheck this. So without this check lock for reference clock, it will not automatically set the MXG to refer to external reference. So let's go to that. Okay. And sorry, we should go to MXG selected active so that it shows on the UI, and then we can select it. So let's go to device property and check this too, and click OK. Then we load the file. So I created 40 meg, 60 meg, 100 meg, and 20 meg. So if you are aware, this analysis bandwidth is solely depends on how wide the bandwidth that you have on the signal generator. So we need that to generate out the signal. When it comes to analyzing the measurements, if you use the traditional spec end, we need to have the same size of analysis bandwidth. But for this PNA, it doesn't need that. So this is one thing to consider. So if you have created some files, you can always recall back And so what you need to do is just MDX. Or if you want to create from scratch, let's go through that. Let's create from scratch. And let's say I want a 40 meg. QPSK signal to start with, and my alpha is 0.25. This is important because we're going to use the same value in the VSA setup. So once you're happy with that, source name, and then so there's some few selections here. So it depends on what you want to do. You want a tone, you want a notch. So for this case, we want to test EVM, so we use a digital modulations. Once you're happy with that, calculate that. So that's what we have, and then we save it as a file that we can recall back later. So QPSK, yep, QPSK. So once you're happy with that, just click OK, and then you auto fill out everything here and apply OK. So as you can see that I'm supposed to pump out at minus 20. Let's look at minus 20 carrier. It doesn't show here. These are the indication telling you that the reference frequency for the ESG is not set up properly. The other way that you can try is go to average bandwidth. Let's set it to auto. And when you set auto and manual, it shouldn't change much if your reference frequency is set correctly. Okay, let's try again. Let's go to, it started with 111 Hertz. Yeah, so as you can see that yeah, it changes quite a lot. Let's go to the ESG web server. So let's auto refresh it, and yeah, so there's no indication saying that the external reference is connected here. Let's do it manually. Let's go to frequency, more, reference oscillator. Currently is internal. Physically I have connections ready, reference out from the PNA and reference in to the MXG. So let's change that to external. So once I have that, I'm happy with that. So as you can see, it changes from minus 64 to minus 31. It's still not correct because we haven't run the calibrations yet. Right? Let's go to calibrations, other calibrations, source power modulations. So this was done before, just the ACP measurements. Let's go to power. So iterations, how many times you want to run, the desired tolerance is what you're going to set. Then we click next. So remember the device still connected, and then we calibrate it. So once we're done, so you will readjust all these measurements. As you can see right now, the band power for the input is close to minus 20 as what we set here. Okay, and I'm going to show you how it looks like on the EXG. So as you can see, that EXG is roughly 1.37, and there's a internal loss of close to 19 dB. And I'm going to show you here, if you change the R path here. So as you can see right now, the signal to noise ratio for the input signal is quite far. What if I change the source to 0 and I click apply and OK? As you can see that the noise floor has gone up and the signal to noise ratio is lesser, but the power is still the same. And of course the EXG value will change accordingly. So it's close to 10 dB offset from previous. We suggest to add in this 10 dB just to increase the signal to noise ratio of your signal. Okay, let's add in another trace, and we want to measure the PR so that we can see how it looks like after the amplifications. Let's set the same reference level so that you can see the ACPR has gone up, the center point has gone up. So let's add in another one, another trace. Then this round we want to measure capture this modulation gain, so that we know where is the modulation area. Let's set the scale to auto scales, or maybe I change that instead of modulation gain. I'll change the modulation distortion. Yeah, I want to see how much distortion it has introduced. So let's go to here. Let's set the same level at 20. Okay, let's do the scale. 20. Yep. So the yellow line is the input, the aqua line is the output, the red line is a modulation distortion that's being introduced through the amplifier. Okay, and then we change this. Let's go to modulation setup. So we had gone through how to create that. We did a source count, and then we do a measurements. So currently it's in band power, and then I want to see the ACP and EVM. Okay, and my ACP is -50, and then this one is 50. So the upper and lower ranges. Then we calculate that and measurement detail. So let's do this. I think it's mentioned in the help file why we need to lower down the equalization aperture just to get better reading. Let's go to get apply, click OK. So this ACP plus EVM. So we have an EVM value of the distortion EVM of 0.62%. Let's add in the output of the EVM so that we can see output here. So it's about 1.58, and now ACP, we don't need to have low input. Let's go to ACP, low input, input. Yep. So you can see just the output of the ACP. If you found out that this is very tricky to read between ACP and EVM in one line, you can just change this. Go to mode, measure, go to multi-band. So band 1, I really just want to, let's say, I want to measure ACP. Then I add in another band, multi-band. So this for the ACP measurements. Then I append another band. Just want to measure the EVM. Okay, and of course, if I want to add in another one, band power, it's up to you how you want to look at. And then you can click OK, and then it just consolidates everything down. It's almost the same that you have to scroll around here, but it's more manageable in the sense. Okay. Ooh, something wrong with that. Could be that it's running on 3 different measurements here right now. So let's say we don't want that. Let's go to mode setup, because I haven't have this band 3 came out yet. Let's remove this one and let's try this, but let's see, it'll be better. No. Okay, it could be a bug. Still working on that. Let's try this. Remove this and let's change to EVM. Looks much better now. Okay, so the next video I'm going to show you how to set up the VSA software to compare the reading of the output EVM versus what we get from the traditional way of measuring using the VSA. Thanks for watching.